Welcome to MET 200, Manufacturing Processes and Material. This section, this lecture, we will talk about non-ferrous metal and alloys. We are still in chapter 6. If you see this chapter, we have a section called the non-ferrous metals. First, we want to answer this question: what is non-ferrous metals? Non-ferrous metals are those materials that are not based on iron. This is in contrast with the steel, where the main element was iron. Some of the most important metal in this category is aluminum, copper, magnesium, titanium, nickel, and etc. These metals, non-ferrous metals, actually they are not as strong as steel. However, they have good strength to weight ratio, which makes it appealing for some application. And another point about this material is that they are more expensive than ferrous metal. They have a good corrosion resistance, high thermal conductivity, as well as electrical conductivity. They have low density, and ease of fabrication is one of the good thing about this non-ferrous metal. This chart, this table shows some of the most important material, non-ferrous material, and their cost per unit volume. As you see, gold is the top on the list, and the cost is going to be 30,000 per unit. Silver is the next one with a huge drop. Then we have other material: molybdenum, nickel, titanium. As you see down in this chart, we have carbon steel, which is the unit price. It's very low comparing with aluminum, for example. Aluminum is 2, 3, and titanium is very expensive compared with the carbon steel. One good example that shows the application of non-ferrous metal is this turbofan jet engine. As you see, we have many non-ferrous metals in this jet engine. 38% of the whole structure is titanium, and then we have 37% nickel, and then we have aluminum 5%. One of the main reasons using non-ferrous metal, there are many reasons, but one big reason is to reduce the weight of this turbofan jet engine. One of the non-ferrous metal is aluminum. Aluminum can be used with alloying element. Therefore, we can use aluminum alloys to have a better strength, because pure aluminum is soft, but when we add some alloying element, it becomes harder and strong material. The important characteristic of aluminum is that they have a high strength to weight ratio. Here in this table shows the weight, the density, and Young modulus. Young modulus shows the stiffness of material. If you have a stress versus a strain, the slope of this curve is called Young modulus. So if one material has a steeper curvature, E represent here is going to be larger. Okay, so we want to compare aluminum with the steel. Aluminum has the 69 gigapascal, or if you want to compare it, convert it to psi, so it's going to be 10 mega psi, and steel has about 30 psi, so it's way larger than aluminum steel, I mean. And the density, but the density, if you see, is 7,800, but this is about 1/3 of the steel. But there are some ways to increase the modulus if weight is a criteria, is a limit. You cannot use steel. Other characteristics of aluminum is that it has a good resistance to corrosion in many chemical container. It's very important property that we have to take into consideration. Thermal conductivity and electrical conductivity is the next property. It's a non-toxic, and it's a reflective material, and it's very formable. Some of the application of aluminum is in industry. We use it in aircrafts. It was told that in aircraft 747 almost we have 82% of this airplane was made of aluminum. 82% by weight. And it's well recognized that the Dreamliner, this airplane, was made of composite, and the fuselage was mainly made of composite, but still we have 20% of the body made of aluminum. Aluminum has still a lot of application in this Dreamliner airplane. If you wanted to distinguish aluminum from steel from appearance, it has the white color, or somehow white gray color. Almost all overhead power line, they are using aluminum conductor steel reinforcement cable. The outer strand here is aluminum. Aluminum was chosen because of its good conductivity, electrical conductivity, and steel was chosen to provide additional strength for the weight of aluminum in the power line. This chart shows the designation system for aluminum alloy. As you see, we have 4 digits. If it is wrought aluminum, we have this 4 digits without any decimal point, but in the cast aluminum we have 1 decimal point here, all of them. And for the aluminum with 99%, we have 1 in the first digit, the most left one. But if the alloying, we have some alloying element, then the name is going to be changed. For example, here copper. If you have copper, then it takes digit 2. And then if you have manganese, it takes the digit 3. This table shows the mechanical property of aluminum alloys. As you see here, where we don't have much alloying element, the ultimate tensile strength is 90 megapascal, and the yield strength is 35, and we have a good elongation. As you see, 35% up to 45. As we add more alloying element in aluminum, the ultimate strength goes up, as well as the yield strength that goes up. Elongation decreases. Here we have a drop from 35 to 9, and there are some aluminum 75 that the strength is competitive to the steel alloys. The yield strength of steel can be 250 to 700 megapascal, and that is very important. And we see for this aluminum alloy, we have about this, not exactly the same, but close to that, the yield strength of steel, but the elongation, again similar to the previous alloy, was dropped. This table shows the manufacturing characteristic of aluminum alloy. We have corrosion resistance, machinability, and weldability. And in the pure, almost pure iron, pure aluminum, we have a good corrosion resistance, because aluminum, when we have pure aluminum, it will react with the oxygen and gives you aluminum oxide or alumina. The machinability is a CD. A represent excellent, C or D represent poor property. Weldability of this alloy is good. As we increase as we add more alloying element, for example this one, the corrosion resistance decreases, as well as the weldability becomes very hard to weld this type of aluminum alloy. About the aluminum production, the Bayer process is used to produce aluminum, pure aluminum metal from bauxite. The next non-ferrous metal is magnesium. Magnesium is very light, and because it is not a strong material, in pure state it doesn't have many application, so it has to be alloyed with other material, and can be used as a rod or cast form. It's relatively easy to machine. One problem with the magnesium is that it oxidizes rapidly, so care must be taken to avoid fire hazard. Some of the application of magnesium alloy are in the aircraft, missile component, or bicycle. This is one of the application of magnesium in auto industry. And remember that magnesium is the third most abundant metal in Earth, most of the magnesium are coming from seawater. But the extraction of magnesium from seawater is very difficult. That's why it is expensive metal. Copper is the next non-ferrous metal. It has a property somewhat similar to aluminum and its alloys. It's soft and reddish metal, one of the oldest metal known to human. It has a good corrosion resistance property, and it's known as the best conductor of electricity and heat. Sometimes copper alloy are attractive for application in which a combination of electrical property, electrical, mechanical, non-magnetic, corrosion resistant, thermal conductivity, wear resistant, and etc. are required. As you see here, we have one example, a copper that was used in a Higgs exchanger, because it's a very it's a very good thermal conductor material. In the copper alloy, we can add various alloy elements to improve the copper alloy property. Also, we can do heat treatment to improve manufacturing characteristics. There are two examples of copper alloy. One is brass, and the other one is bronze. In the brass, which is an alloy of copper and zinc. This is one of the earliest alloy developed and has numerous applications, including decorative material. The amount of zinc varies from 5 to 40%, and copper can be 65 up to 75%. The next one is bronze. Bronze is alloy of copper and tin. The next metal is zinc. Zinc has a low melting point, about 419 degrees Celsius, which makes it attractive as a casting metal, especially die casting. The density of zinc is about 7,130. For steel, it's 7,800 kilogram meter cube. And there is no structural engineering uses in pure state. Normally used as a sacrificial anode to protect the steel, and also used in alloy with copper to produce brass. We mentioned that it can be used as a brass material, and also it can be used in the steel industry to galvanize the steel, so it's going to be coated onto steel or iron, and plating. The next metal is a lead metal, which has a high density. The density of lead is about 11,350 kilogram versus meter here, which as you know, steel has 7,800. This is way above the steel density, so the lead is very heavy material. The melting temperature of lead is low, is about 327 degrees Celsius. It has low strength. Strength is low. Hardness is low. Ductility in lead is high. It has a good corrosion resistance property. It has application for soldering, bearing, ammunition, X-ray protection. The next metal is titanium. Titanium has a low density, is 4.5 or 4,500 kilogram meter cube. As you see, titanium density, Young modulus, and steel. It has a strength similar to steel. Close to steel, but the density is way lower, about half of the steel. So because of this low density and high strength, it has a good use in aerospace industry. It has a highly corrosion resistance property, as well as it's abundant in nature. About 0.1%. I'm sorry, it's 1% of the Earth's crust has titanium, and then aluminum is about 8%. Aluminum. This metal melts at 1670 degrees Celsius. Steel melts at 1400 degrees Celsius. Just to give you some idea that titanium has a higher melting point. So there are some steel that melts at 1500 degrees Celsius. Because of the unique phases that are present in titanium, the use of titanium is restricted to 400 degrees Celsius. If it goes above this temperature, the mixture of phases changes a lot, so that's why it's restricted to this melting point, this temperature. Titanium has good corrosion resistance property. Because of that, it has a lot of use in the marine component, as well as a prosthetic implant. As you see here, titanium is used in heat exchanger. Heat exchanger, the environment is harsh in terms of corrosion environment. Because of that, the titanium is selected for this industry. And we have alloying element that use with titanium. Some of them are aluminum, magnesium, tin, and vanadium. Nickel alloy, or nickel, pure nickel, was discovered in 1751. It's similar to magnesium. It has a lot of application in the steel industry because it can impart strength, toughness, corrosion resistance property to steel. One thing about nickel is that it's very magnetic. At the density of nickel is about 8.9 heavier than steel, because let me write it in metric system. 8,900 for steel, 7,800. So it's heavier than a stainless steel or a steel. Similar to chromium, it has a good corrosion resistance property. When you use it in pure state, it's brittle. It can be alloyed with copper to produce copper nickel for coinage, and moly for corrosion resistance, valve parts. And it has a lot of application in aerospace, engine part. One is the blade, jet engine blade, and these are some of the common name for nickel. Nichrome means nickel plus chromium plus iron. Invar and covar means nickel plus iron, and etc. For Inconel, we have different material in this category. One well-known Inconel material is 718. The primary application of superalloy is in aerospace industry, such as turbine no engine blade. This is one of them. The one problem with turbine engine is that because we are dealing with high temperature. At high temperature, one type of failure that happens is called creep. Creep happens at high temperature. So if you want to avoid this, it's recommended to use a single structure, single crystal. Single crystal. When you use single crystal, you reduce the grain boundary, and this type of steel, you can create a single single grain. You can create a stainless steel single grain. It's going to be much more difficult, but the fabrication of blade with a single grain is going to be easier if you use superalloy. The next metal is chromium. Chromium has a corrosion resistant property similar to nickel. It can form very good oxide layer, which is very strong, and it is brittle when you use it in pure state. It has a lot of application in stainless steel. We mentioned it before. What happens, is austenite stabilizer, so you can have austenite at room temperature. You can use chromium with nickel and molybdenum to produce a strong steel for bicycle, motorcycle frame tubes. Besides these metals that we mentioned, we have other type of metals that are called refractory metals. Refractory metals means that they can withstand up to very high temperature, and some of them are here we have 5. Tungsten is one, niobium, Nb, and molybdenum is another refractory metal. Here are some takeaway from this lecture. As we mentioned that aluminum is well known for its low density. It has a high electrical and thermal conductivity. It has a good corrosion resistance. This is because it can form a tough oxide film on the surface. So then also it has a good strength to weight ratio. The next metal was magnesium. Has a low density. Also, it has good strength to weight ratio. Seawater is a source of magnesium, but it is difficult to extract magnesium. That's why it's expensive material. The next metal is titanium. Also, it's noted for its high strength to weight ratio. It has a good corrosion resistance, and high temperature strength is another property. The zinc was the next metal. It can be used for die casting. It's easy metal to cast. That's why it's used in die casting. Also, it has a low melting temperature. It can be used as a coating in galvanized steel to protect the steel from corrosion. And lastly we talked about refractory metals, which means the metal that can withstand at a high temperature service. Please contact me if you have any concern about this lecture. You can use my office number, or you can use my email address. Here is the email address. I try to address your concern as soon as possible. Also, you need immediate assistance. Please use the number I provided through email last week.